Hi, so we're going to demo solving a Code Wars challenge. This one is valid parentheses. I'm going to go ahead and solve this in JavaScript, just because that's the language that I like to practice with. So let's take a look at this problem. Write a function that takes a string of parentheses and determines if the order of the parentheses is valid. Function should return true if the string is valid and false if it's invalid. So it looks like we're counting to see if the opening parentheses match the closing parentheses, and there's not a closing parenthesis before we get to an opening parenthesis. We'll have input that's between 1 and 100, and everything will only be parentheses, so that's nice. Empty strings are considered balanced, will be tested. Cool. So we're going to have to figure out how to solve this problem. So I'm going to go ahead and think about how we're actually going to do this testing. So I've actually got a solution in mind for this already, but if you haven't done this kind of parentheses balancing, then figuring out what is the strategy to do this is kind of tricky. So one way that you could do this would be to think about the count of how many open parentheses you've seen, and then decrement that as you close those parentheses. If you ever go below 0, if you hit a closing parenthesis when you should only have open parentheses, if you sort of decrement below 0, then that's invalid, and if you get to the end, then the number should be 0. So let's do the counting strategy, and we can see if that works. And if it doesn't work, then we can try and come up with some cases why it doesn't work, and then figure out how to fix it. So we're going to say let left paren count equal 0, and then for let character in the paren string, we want to say if the char is the open parenthesis, then we want to left paren count is equal 1. Else, we've only got the two cases that we have to worry about. If we thought that the strings would not be just consisting of the parentheses, then we'd have to deal with the other cases. But for this, we don't have to worry about it. We'll do left paren count minus equal 1, because we're sort of closing that parenthesis, and so we've sort of returned back to a neutral state for each one that we close. But then we also want to check, so if the left paren count is less than 0, then we want to return false, and then so this is early return as we're looping through if we ever go below 0, and then here if the left paren count is equal to 0, then we want to return true, and then otherwise we want to return false. And we can come back and clean this up in a minute. So first, let's just go ahead and run this and see what we are getting from the tests here. Okay, so we passed 2 tests, so this is close. Expected false to equal true, should return true for valid parentheses. So should return false for invalid parentheses, should return true for empty strings. Test failed for input, and we just have the open and close, so expected false to equal true. So first, I think that this is already annoying me. I am evaluating this Boolean here and then returning the literal true or false. We can just return the Boolean here. We don't have to do this computation and then return a different thing. Just feels cleaner to return yes. If this is 0, then that's what we care about. So let's walk here. I'm gonna just run the test again, make sure I'm getting the same result. Yep. Let's think about what must be happening here. So we've run the tests for this, and we're getting false. My guess is that I've messed this up somehow. Let's console log the character and test this again and see. Okay, so the log says 0. So I've done something dumb and just forgotten the right iterator to use in JavaScript. There are two iterators here, the in and of iterator, and I've mixed up in and of. Of is the like array element iterator, and in is like an object key iterator. Strings, like a lot of JavaScript objects, can work as either one, but if you use the wrong one, the iteration won't be the thing that you expect. So that would have been something like key in parent string, and that's like the index. So paren stir key would have been the character that we wanted, but I don't actually want that. I want character of. Let's do this, and just a logging. Let's see, our logs have gotten eaten somewhere. Okay, so this test seems to work. These are like the basic tests, and then if we press attempt, then this has a larger suite of tests that it runs, some random tests and some large tests. I think this solution's pretty nice. It's just counting things and using sort of the properties of that count to decide. The other sort of classic solution to parentheses checking would be a stack-based solution, where you're pushing and popping from a stack, and depending on when you push and pop, what character is on the top of the stack, that tells you whether or not you're valid. That's really useful if you've got more things going on than just the parentheses. But for this case, this is a pretty simple way to solve it. So I'm going to go ahead and leave it at that. Let's see what other people have solved it with. So this looks like a very similar solution, just counting. Yeah, this is almost the same as mine. This has some comments that I can't read. So this looks like it's the stack-based solution. So we're pushing parentheses onto the stack, and then when we're popping, we're checking whether or not the thing that we pop is indeed the right kind of thing. this isn't actually necessary for this particular problem, but if we had other kinds of parentheses that we were also trying to check if they were validly nested, we would have to do this kind of solution. This also looks like it's a stack-based solution. This is doing some early checking. Return. So this is actually, no, this is kind of cool. So this is doing a recursive solution. Not totally sure I follow it. Let me see. So if the string length is false, or is falsy, so if the string is empty, then it's true if the depth is 0. So they take a string and a depth, because we are, I guess, doing this recursion and we want to hit like a base case and sort of see how deep we are in the recursion. This one's hairy and I don't love it. So string slice 1. So this is taking a piece of the string and checking if that has valid parentheses. So if the depth is less than 0, return false. So the depth should never be less than 0. This is a pretty clever little solution. It's doing the same kind of counting using this depth parameter, as far as I can tell, where if we've got a left brace, if we've got a left paren, then it's incrementing or decrementing this depth and then recursing. I think it's way too clever. It's like that's sort of a silly way to do it, but cool for sure. Okay, interesting. This is a cool solution. So this counts. So this counts to 100, and each time it's counting, it's replacing one of the internal sets of parentheses with the empty string. So this is actually kind of cool. So it takes advantage of the fact that if you've got this set of all of these nested parentheses, then somewhere in the middle there has to be a set that is like a left and a right next to each other, and then if you remove them, that property needs to still hold. And so if you do that 100 times, because the the instruction said that it could only be 100 characters long, this string, then if you do that 100 times, then the string should be empty if you've done that replace operation. So that's kind of clever. I think it's it's neat. I wouldn't solve it this way, but it's kind of cool. This looks like the same solution as I had, but with a switch statement instead of conditional. That's kind of cool. So this this uses a property of JavaScript regular expression. So this is the regular expression constructor, and it attempts to construct a regular expression from the string. And JavaScript regular expressions require that the parentheses be matching. They can't be like invalidly nested. And those nesting rules happen to coincide with the rules of this puzzle. And so if you can construct a valid regular expression, then they're valid, they're balanced. And if you can't, then it's false. So it uses the regular expression constructor and the try-catch to implement this logic. Like many of these things, very silly, but really clever. Okay, here we've got the one-liner, valid parentheses. So we've got in here, we're assigning this valid parentheses, like name, we're binding it to this function that's created here with the like an arrow function. We've got no spacing here because we don't care about readability, just trying to reduce the number of characters. And so P is going to be our string, and it looks like he's spreading it into an array and then calling reduce. So spreading it into an array, it's going to have each character in this array as a separate element. So we're reducing, we're starting from 0, and we've got the character, and this V is going to be our accumulator. And we're doing a ternary. If C is less than 0, then it's C plus, wow, that is a tricky thing to figure out what he's doing. So there's some kind of ternary here. If C is less than 0, you just leave C alone and return that. I was mistaken. C is the accumulator here, and V is the next value. So if the accumulator has reached, like if it's gotten below 0, if we've counted, I think I'm just at high level, this is the same logic as my solution. It's counting based on whether or not the character is a left paren or a right paren. But it's implementing into this very terse fashion, sort of hard to reason about. So if it's dropped below 0, then we know that we're false, and we're just gonna, it's sort of using this ternary as our early return. It'll still go through the rest of the iteration, but it'll sort of stop mutating the value. But if we haven't gotten below 0, then we're doing this thing, which is C plus V equals this minus V equals this. So I'm guessing that this is using some kind of coercion here. So I can't remember what integer value, what like number value true and false coerce to. But I'm guessing that like true minus false is probably 1, and then false minus true is going to end up being -1. And so we're going to go up or down in the accumulator depending on whether or not it was a left parenthesis or a right parenthesis. This is another clever solution, very terse, but pretty difficult to decipher. Here's the same. I guess this was actually mine. A lot more that look like they're the same. This is another stack-based solution. Cool. So it's fun to take a look at the other solutions after you've solved some problem. All right, that's it.